Assalamualaikum and hello everyone. My name Nurul Najwa binti Ahmad. So today I will explain this question. Find the least square solution of the linear system AX equal to B given by matrix A 269, 786, 453 and 387. Then for matrix B 7682. Let's go ahead. Just find A transpose times A. Okay, so A transpose will give us 2743, 6858 and 9637. Then we were going to multiply this 269, 786, 453 and 387, which is A. Okay, so this is gonna give us A 3 by 3. So we got 78, 112, 93, 112, 189, 173, 93, 173 and 175. So now we have to compute A transpose B 2743, 6858, 9637 times B 7682. So this is gonna give us A3 by 1. So we have 94, 146 and 137. Okay, so now we have A transpose A and then we have A transpose times B, which is here. Okay, now we have 78, 112, 93, 112, 189, 173, 93, 173 and 175 times x1, x2, x3 equal to 94, 146 and 137. Okay, next A transpose A inverse. We were gonna take the inverse of 78, 112, 93, 112, 189, 173, 93, 173 and 175. So that gonna be 1 over the determinant of this matrix is 100,463, and then we were gonna multiply this by the matrix 3146, negative 3511, 1799, negative 511, 5001, negative 3078, 1799, negative 3078 and 2198. Okay, we will take this and multiply by our vector 94, 146 and 137. So x1, x2 and x3 will be equal to 1 over 19463 times 3146, negative 3511, 1799, negative 3511, 5001, negative 3078, 1799, negative 3078 and 2198 times 64, 146 and 137. So this will give us 1 over 19463 times 29581, negative 21574 and 20844. For x1 we got 1.5199. For x2 we got negative 1.1085 and for x3 we got 1.0710. Alright, this is our least squares. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for the next question, which is by using Gram-Schmidt, find the orthogonal basis and after that orthonormal basis for chord, which is A equal to span 269, 786, 453 and 387. For the next step, we let V1 equal to U1 by starting with column 1, 2743, and then to find V2, we use formula V2 minus V2 multiplied with U1 over U1 multiply U1, and then multiply U1. So as I show that 6858 multiply show that for V2 and then V2 multiply with U1 6858 multiply with 2743 over U1 multiply U1 so 2743 multiply with 2743 and then multiply with again U1 2 and then for the next step we simplify from 6858 minus 112 over 78 multiply with 2743 and then we get 6858 minus 112 over 39 392 over 39 224 over 39 and lastly 56 over 13. So the answer that we will get for V2 is 122 over 39, negative 80 over 39, negative 29 over 39, and lastly 48 over 13. Next step to find V3, we just add in another step at the back, which is V3 multiplied with U2 over U2 multiply U2 and multiply with U2. So we can look at the calculation and then we simplify. We get 9637 minus 93 over 78 multiplied with 2743 minus 1539 over 1099 multiplied with 122 over 39 and then negative 80 over 39 negative 29 over 39 and lastly 48 over 13. And lastly for the next step is we simplify until the answer that we get is 2.2348, 0.5263, negative 0.7279 and lastly negative 1.7475. So the conclusion that can we write is an orthogonal for V1, V2 and V3 is for V1 is 2743, V2 is 122 over 39, negative 80 over 39, negative 29 over 39 and lastly 48 over 13. And lastly for V3 is 2.2348, 0.5263, negative 0.7279 and lastly negative 1.7475. Next, to find orthonormal basis, we use this formula and then we substitute the value which is V1 equal to square root 2 square plus 7 square plus 4 square plus 3 square, which is from column 1, and then the answer we get square root 78 and then for V2 square root 112 over 39 square plus negative 80 over 39 square plus negative 29 over 39 square plus 48 over 13 square and then the answer for V2 we get square root 1099 over 39. Next for the last step to find V3 is we still use the same step and then the answer we get square root of 8.8549 but we not stop only here and then we continue like we can see here 2 column 1 over the answer for V1 that we get before this. So the answer we get is 2 over square root 78, and then 7 over square root 78, that 4 over square root 78, and lastly 3 over square root 78. And then we still from that we use the same step for V2, and the answer we get 112 over 39 per square root 1099 over 39, and then negative 80 over 39 over square root 1099 over 79, and 39 over 39, and then until for the row 4 we get 48 over 13 over square root 1099 over 39. Okay, for the last step for V3 we still use the same. So the answer we get 2.2348 over square root 8.8549, and then 0.5263 over square root 8.8549, and then negative 0.7279 over square root 8.8549, and lastly we get negative 1.7475 over square root 8.8549.
Hi, my name is Nofatiha. Okay, let's we continue with question 3. Solve x using QR factorization. Okay, let's we recall x a, b, and m time n metric. The QR factorization for a is writing a is a product of q and r. Okay, where q is an m time n metric consisting of columns that form an orthonormal basis for column a, and r is n time n invertible upper trigonometric. Okay, for first step, we will use back all the following value to get what the value of matrix Q and R. Okay, for to find the value of matrix Q, we need to find the orthonormal basis. Don't worry, if you remember at the previous slide of previous question, Sharifa has been shared about it. So here we will just to come up back that orthonormal basis value has the matrix Q value. Okay, for the next step, we can continue with how to find the value of metric R. Here what we can see, to find metric of R, we can use formula R equal to Q transpose multiplied with A. Okay, after we already know what the value of metric R, we can use the formula to find the value of X. By we use the formula Rx equal to Q transpose multiplied with D. Okay, after that, to know what how to find the value of x, we rearrange r into the right side. So the new formula what we can get is x equal to r inverse multiplied with q transpose and multiplied with b. And at the end, we will get the answer for metric for x is 1.519x6, negative 1.10x46, and 1.07096. So for this question, it will be solved. Thank you.
Okay, so let's use Mathematica programming to find the orthogonal basis and then orthonormal basis for A span 274368589637. So the first step is to put the matrix A and also V1 equal to 2743, V2 6858, V3 9637. So the next step is to find U1, U2, and also U3. So U1 is equal to V1, which is 2743. U2 is equal to V2 minus V2 times U1 divided by U1 times U1 times U1, which is equal to 122 over 39, negative 80 over 39, negative 29 over 39, 48 over 13. And U3 is equal to V3 minus V3 times U1 divided by U1 times U1 minus V3 times U2 divided by U2 times U2 times U2, which is equal to 2,456 over 1,099, 1,157 over 2,198, negative 800 over 1,099, and also negative 3,841 over 2,198. So the orthogonal basis for the matrix is 2743, 3.12821, negative 2.05128, negative 0.74359, 3.69231, 2.23476, 0.526388, negative 0.727934, negative 1.7475. So next we will going to find the orthonormal for the matrix A. So the first step is to normalize each of the U1, U2, and U3. And next, we put the orthonormal basis in matrix form. So the answer is 0.226455, 0.792594, 0.452911, 0.339683, 0.589289, negative 0.386419, negative 0.140077, 0.965555, 0.750999, 0.176895, negative 0.244625, negative 0.587253. Next, we will going to solve X using QR factorization method in Mathematica programming. So the first step is to input the matrix A and matrix B into the program. Next, we will need to find the Q transpose and also the R using the command QR decomposition of A. So we got our Q transpose in matrix form and also R in matrix form. So the last step is X is equal to inverse R times Q transpose times B. So the final answer for X is 1.51986, negative 1.10846, and also 1.07096.